Alright, so 4.2 was proving that proving that polygons were congruent, but we talked a lot about triangles. And this one it says, in the diagram, triangle ABC is congruent to DEF. Complete each statement. So remember that the order of the letters is important, right? I could either use the diagram that's there, or I could use the letters without even looking at the diagram. So if I asked you to find the one that's congruent to the measure of angle A, it would be what? D. And then FD would match with what? AC or CA, right? They're both the same thing. So you could say CA, you could say AC. The order of the letters in a segment don't matter. And then it says triangle EDF. So it rearranged the letters to go middle, first, last, which means I have to follow that same pattern on the first one, which would put the letters in what order? BAC. Good. This one says use the given diagram to write a proof showing the two triangles are congruent. So I'm going off of what's in this picture. Which is what? What information is in that picture that's going to help you in your proof? Nick. So what do those little marks tell you? So specifically pick two. Pick a pair. Okay, so WX is congruent to XY. And the other pair is what? YZ is congruent to ZW. What else is marked in this diagram? Alexis? Well, the right angles are marked, so angle, let's keep that separate though, because let's do the congruence first. What else is marked as congruent in here? Emily? Angle W and angle Y are congruent. So the reason we know all this is what? It's given, okay? And then, Alexis, I'm just going to state yours separate just so we can identify. So XZW is a right angle. And angle XZY is a right angle. Which is also given. So you could have done them all in one step. I just want to differentiate between congruent and right angle. Okay, but the reason's the same. All right, so now what other piece of information do I have from this diagram? Chris? So I could have used that instead of this, right? Well, I can do it here. Let's keep going. XZ is perpendicular to WY. And how do you know that? So what's that mean? There's a right angle, which means it's perpendicular, right? What's the word perpendicular mean? That they form a right angle, right? So if I'm saying they're perpendicular, what am I using? How do you know what perpendicular is? It's a definition of perpendicular, right? This is not the only way to do it, but I'm going with this because this is working, okay? I'll go back and do some variations in a second. Okay, so now what? What else is in that picture that we haven't used, Loris?
Angle WXC is congruent to angle YXC because of the third angle.
Okay, well first, before we do that, we have to show that those right angles are congruent. So that is going to be a step, right? But I have to show that there's two pairs of congruent angles first. So there's a couple ways to do it, but how could I state that WX or WZX is congruent to X angle, XZY? So using the information that we have, what's true about perpendicular lines? They form congruent adjacent angles. So perpendicular lines, which was a theorem, form congruent adjacent angles. Okay, so I didn't need two if I was going to do that, but you can use two. You could have also said if they're right angle, then they equal 90, and then they would equal each other, which would have been the definition of a right angle, and then substitution. So you could have done it that way.
So for step 4, you don't need to know like any of that. You could literally say.
Yeah. I don't even know the name of that. I don't use it
So.
because it changes every book.
So literally, all the proofs we do, you don't need to really, as long as you can state.
Exactly. Yeah. I'd rather you know what it says over the name of it any day. Right? You're never going to get a standardized test that asks you what's the name of all these proofs.
Couldn't that also be given?
The fact that they're congruent is not given. The fact that they're right angles is given. So you know that if they're both right angles, they're congruent. But that's, if they were literally marked with the arcs, that's the only time you can say they're congruent directly from the picture.
So right angle signs can't count as congruent.
Correct. Does that make sense?
Yeah.
Okay.
They're both letters Z though.
Yeah, but you can't use Z because Z is a shared vertex. So you have to use all three letters. Around.
I forgot the theorem, so I substituted the value for
That's fine.
90.
So you said they equal 90, and then substitution, that's fine too.
Can you go from step 2 to step 4? So like.
No. In order to use 4, you have to state that those lines are perpendicular. So in order to use that theorem, you have to give, the if has to be that they're perpendicular, which is not stated in 2. I kind of would let you go from the given to 3. Like, I don't know if I'd make you do 2. I'd probably give it to you. But you can't say if they're perpendicular, they form congruent adjacent angles without stating that they're perpendicular. Okay, so now I've got these two angles are congruent. And then, Lourdes, I would go to that next step, which says angle WXZ is congruent to angle YXZ. And that's third angles congruence. Okay, so now I've got the third angles, 1, 2, 3. So the only way we know how to prove that these two are congruent is if all 3 pairs of sides and all 3 pairs of angles are congruent. Have I hit that yet? How many pairs of sides do we know are congruent? 2. How many pairs of angles? 3. What am I missing? The last pair of sides, which is what? It's the one that's the same, right? We know it's going to be the same. So what's it called when we say that a side equals itself? Reflexive. And you do have to make that statement. Sure. Yeah. All right, so now do I have all 3 pairs of sides and all 3 pairs of angles? Yes. So the last statement is triangle, and it just said to prove that these two are congruent. So the order of the letters doesn't matter how you pick it the first time, but you have to be consistent with the second time. So I went top angle, which had the 3 arcs, left angle, which had the 1 arc, to 2 arcs, which means I have to do the same thing on the other side. The top angle that has the 2 arcs, the right angle that has the 1 arc, and the angle on the right, not the right angle, the angle on the right that has the 1 arc, and then the actual right angle that has the 2 arcs. And this is definition of congruent triangles. X, W, Z.
Because I don't think we did that one.
We did W and Y.
Oh.
Yeah, those are the only ones you can use a single letter on because it's the only one that doesn't have a shared vertex. But yeah, if we did not do that, we would have had to. But we did. We did it in the very beginning. Questions? So again, by the end of the chapter, we're going to know shortcuts how to prove these where you wouldn't have to prove all 3 angles and all 3 sides, but for right now, that's where you're at. Okay, so this one says use the plan to prove the third angles theorem. So you're not allowed to use the third angles theorem when you're given something like this. You're trying to prove it, okay? So it told you that angle A is congruent to angle D, angle B is congruent to angle E, and you're trying to prove that angle C is congruent to angle F. So where do I start? The given, angle A is congruent to angle D, angle B is congruent to angle E. So does it make sense that the third angles have to be congruent? Why? They both add up to 180. If they're both the same values, then I subtract both of them. They're going to equal the same value, right? So, okay, so if they add up to 180, how do I use that? How do I state that? Lourdes.
Angle A plus angle B plus angle C equals 180 triangle something.
Good. And the same is true the other side, right? Angle D plus angle E plus angle F equals 180. Same reason. Before you just say what? Yeah. So you can't use third angles. You're trying to prove third angles. Yep.
Like, I did that, but I like made it like 2 separate ones.
That's fine. It doesn't matter. All right, so now what? Chris. So you substitute it in?
Yeah.
Okay.
Angle B plus angle E plus angle C equals 180.
So the only thing is you would want the same thing to be, eventually you're going to get them equal to each other. You'd want the same thing on either side. So I would have done either F to both or C to both, which you could do either way. Okay? Yeah, so I'm going to eventually set them equal to each other. I could have done it in 3, or I could have done this in 3 and then done it in 4. It doesn't matter. But yeah, now that they both equal 180, so this step is substitution. Mm-hmm.
How come you changed angle C to angle F?
Oh, yeah, so I'm so sorry. Chris, you needed to change the A to the D or the B to the E, right? So I should have called that, sorry. Angle A plus angle B plus angle C equals angle D plus angle E plus angle F. And that's substitution. If they both equal 180, then they both equal each other, okay? Now I can make, yep. So because you're replacing a value with what it equals, substitution is a better option. They actually, even your own book flip-flops between those two. But usually when you're taking a value like 180 and you're replacing it with something, then it would be the better option, substitution. Okay, so now I know that A equals D, right? So I can substitute D in the place of A. So this would again be substitution. And what happens if I've got the same thing on either side of the equal sign? Can I get rid of that? How? Subtraction. So I can say angle B plus angle C equals angle E plus angle F.
Why is number 4 substitution and not transitive?
Because I literally took A and replaced A with D, which is what the value equals, right? Yeah.
Would you do it all at one time and replace B with E?
Yeah, so I actually am going to do it again, and you could have combined steps. Okay, so what else can I replace now? What's the other congruent part that I haven't used? B is congruent to E, so I can say that angle E plus angle C equals angle E plus angle F, which is also substitution. And then again, same thing on either side of the equal sign. So I can get down to angle C equals, or is congruent to angle F. And the reason is subtraction. Good.
This is Chris.
Mm-hmm.
I added an extra step after, like, I got angle C equals angle F, and I put angle C is congruent to angle F.
Yeah, it's fine. That's fine. Remember I said, like, sometimes you'll see it, like, it's definition of congruence, which is totally right. If you can get to step 7 without having to do it, I figure I'll give you the credit for it. There's such a similar step, but it's definitely not wrong. So the good news is that now that you know this theorem, you don't ever have to go through all this work again. So it's good proof to practice good practice to do your proofs. But if I were to give you this given and this proof, which most likely I won't, but if I were to give you this given and proof, you should be able to do this in one step, and your reason is third angles theorem. Okay? Alejandro.
Step 3, like this step, because I went
Did you substitute both at the same time?
Well, no, I just did a step where I put measure of angle C equals measure of angle F, and then I put subtraction as well.
Before you do that, you have to make sure that you've got the same angles on both sides. So you can substitute both at the same time. Like I could have said angle D plus angle E plus angle C equals angle D plus angle E plus angle F. And that's substitution. That's fine. You did it in one step. That's fine. And then subtract them off would be subtraction. You could have done that in one step. But you definitely have to replace it so that the same thing is on either side of the equal sign before you subtract it. Okay, so note that this word says challenge at the beginning. So this is a challenge for section 2, but by the end of this chapter, this is a fairly reasonable proof. Okay, so don't just see a word challenge and say it's too hard, I'm not going to try it, right? First of all, with proofs, you got to at least give me something. Don't ever leave them blank. Question mark means you lose credit on homework, okay? You can give me something here. So it says that WX is perpendicular to VZ at point Y, and Y is the midpoint of WX. And then it says VW, which is this side here, is congruent to VX, and ray VZ bisects angle WVX. And the other thing is a right angle here that I can mark. All right, so give me information based on this. Let's just say we're going to state the given all at once to get it out of the way. Okay, everything that's given. Okay, and we're going to say that the reason is given. Okay, now why? What can we figure out from there? Matt?
Perpendicular lines make right angles.
Go a step further. What kind of angles does it form? Congruent adjacent angles. So that saves you a step, right? So if they're perpendicular, then angle WYV is congruent to angle XYV, because perpendicular lines form congruent adjacent angles. Okay? So now I've got one pair of congruent sides and one pair of congruent angles. What other piece of information did it give you? Okay, so it gave us that Y is the midpoint of WX. So what we know about a midpoint is that it divides the segment into two equal parts. So now I can say that WY is congruent to YX, and the reason would be the definition of the midpoint. So now I've got two pairs of congruent sides, one pair of congruent angles. The next thing it gives me, which I already stated, is that VW is equal to VX. And then the last thing is that ray VZ bisects angle WVX. So if it bisects it, then it cuts it into two congruent angles. So I can say that angle WVY is congruent to angle YVX, and that's the definition of an angle bisector. So now I've got two pairs of sides and two pairs of angles. Now let's look back at the picture and see if there's any additional information that's there that we could use. I've got this reflexive side, so I can say VY is congruent to VY, and that would be reflexive. So now I've got three pairs of sides and two pairs of angles, but I still haven't used that last thing, which is the third angles theorem, which says that if two angles in two triangles are congruent, then the last pair would also be congruent. So angle W is congruent to angle X, and that's third angles theorem. And now I've proved that all three pairs of sides are congruent, all three pairs of angles are congruent, which is enough to state that triangle VWY is congruent to triangle VXY. And that would be triangle, or definition of congruent triangles. And that's it.